Good afternoon, class. We are looking at trigonometric functions, section 6.2, graphs of other trig functions. So we looked at graphs of sine and cosine, and now we're going to look at graphs of tangent, cotangent, cosecant, and secant functions. So graphing functions y equals a tan omega x plus b, y equals a cotangent omega x plus b, a cosecant omega x plus c, and a secant omega x plus b. So recall we looked at graphs of sinusoidal functions sine and cosine, and the easy way was, because sine and cosine, the basic one has a period of 2 pi, we cut it into 4 pieces, from 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi, and we make 4 arcs. 1, 2, 3, 4. And the important points are the 3 intercepts and the max and mean. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0, and you have the graph. We do the same thing with the cosine. And in that case, we have 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, comma 1. We also notice the relationship between a sine and cosine as far as the graph is concerned. If you move by pi over 2, you get from one to the other one. For example, cosine of x minus pi over 2. If you move this to the right by pi over 2, you get the sine function. Now, if instead of basic sine or cosine, we have y equals a sine omega x, we are assuming a is positive, omega is positive, the period is 2 pi over omega. Therefore, when y is sine or cosine, period is t equals 2 pi, amplitude is 1. When y is a sine omega x or y equals a cosine omega x, period t is 2 pi over omega, amplitude is the absolute value of a. So that's the synopsis of what we've learned about sine and cosine. Let's look at other graphs. And in 6.2, we're going to look at graphs of the tangent, cotangent, cosecant, and secant function. And we're going to start with tangent. So let's assume we want to graph y equals tan x, and it's somewhere between negative pi over 3 and pi over 3. So all you have to do, evaluate the function at a few points. For example, let's first start with 0. We know tan of 0 is 0. Pi over 6 is square root of 3 over 2. Pi over 4 is 1. Pi over 3 is square root of 3. And these are, because it's an odd function, they have the same value but negative. So for example, tan of minus pi over 6 is minus tan of pi over 6, so minus square root of 3 over 3. This is negative 1. This is negative square root of 3. And so if you plot those pairs carefully, it looks like something like that. So in essence, it's a portion of a tangent, and it looks like a sort of y equals x cubed, to give you an idea. So it will help you memorize how the graph looks like. Let's expand that, and let's go from minus pi over 2 to pi over 2. Again, 0, pi over 6, pi over 4, pi over 3, just as here, we are going to repeat that. But what happens at pi over 2? We're going to say it's undefined. And what happens is that, remember, tangent is sine over cosine. So at pi over 2, cosine is 0. So it gives rise to the concept of a vertical asymptote. So undefined, undefined. So VA at x equals minus pi over 2 and at x equals pi over 2. Vertical asymptotes. So if you graph it, it looks like almost y equals x cubed, and it has a vertical asymptote at x equals pi over 2 and x equals minus pi over 2. So if you expand it indefinitely on the left and right because it's a periodic function, this is one complete cycle. And then the next cycle, it repeats in a manner with a vertical asymptote as follows. Now, y equals tan x equals sine x over cosine x. So as far as the domain is concerned, think about the denominator is cosine, and cosine can't be 0. Cosine is 0 when it's an odd multiple of pi over 2. So 2n plus 1 times pi over 2. Remember, 2n plus 1 means odd. Odd multiples of pi over 2. The range, there is no restriction, is all real numbers. We already know it's an odd function with the period of pi. Vertical asymptotes is when cosine is 0. Cosine is 0 at 2n plus 1 times pi over 2. X-intercept happens when the numerator is 0. Sine x is 0 at n pi. So the fact that tangent is sine over cosine will help us come up with all of these easily. So remember, one complete cycle goes through 0, 0 as a vertical asymptote, x equals minus pi over 2 and x equals pi over 2. And in general, 2n plus 1 times pi over 2 because cosine is 0 there. And by the way, as far as the domain is concerned, we exclude those. So x can be any number except those, right? Y equals 2 tan x minus 1. We are writing that for the basic tan function, the period is pi. VA is x equals 2n plus 1 times pi over 2. X-intercept at n pi comma 0. So the period is pi because this is tan x. That's not changing. And because the period is not changing, the VA is not changing either. 2n plus 1 times pi over 2. In fact, for 2 tan x, the x-intercepts do not change either. But in any event, we start with tan x. Looks like that. Again, pay attention to the main cycle. 0, 0 here, pi over 4, 1, negative pi over 1, 4, negative 1, x equals pi over 2, x equals minus pi over 2, and it goes indefinitely on both sides. So we are going to apply the transformation. We're going to use the 2. That means we're going to multiply by 2. And that means vertical stretch by a factor of 2. Meaning, if you look at just the main one, 0, 0 doesn't change. But this one, pi over 4 remains, 1 becomes 2. Minus pi over 4 remains, negative 1 becomes negative 2. The y coordinate gets multiplied by 2. So pi over 4, 1 becomes pi over 4, 2, 0, 0, because 0 times 2 is the same thing. Doesn't change. Minus pi over 4, negative 1 times 2 is negative 2. That's 2 tan x. So again, we have the same VAs, vertical asymptotes. And finally, negative 1. We're going to bring this down by 1 unit. So shift it down by 1 unit. So when you shift it down by 1 unit, what it does, 0, 0 changes to this point, 0, -1. Negative pi over 4, -2 comes down to negative pi over 4, -3. Pi over 4, 2 becomes pi over 4, 1 because it comes down by 1. And that's the graph of 2 tan x minus 1. So it's shifted down by 1, which means it is not changing the domain or vertical asymptotes, but it does change the x-intercepts, by the way. We are graphing a tan omega x plus by cos 3 tan 2x. And so we know the graph of tan x is the basic one, but we can figure out the period, and the period, which is pi. Now we are going to divide pi by 2. It's important to know it's pi in the case of tan x. In the case of tan omega x, the period for this one is pi over omega, so it gives us pi over 2. Okay. The vertical asymptotes, basically, you divide the period, you just replace this one with period, right? If you want to know what's the vertical asymptote, replace the pi with pi over 2. Class, replace the pi with pi over 2. So you get 2n plus 1 times pi over 4. You want the x-intercepts, n pi comma 0. Replace the pi, because remember, the t is pi, with pi over 2. So n pi over 2, 0. That's how it works as far as knowing important parts. So here's the tan x. We've seen it many times before. We're going to multiply it by 3, which means it has a vertical stretch by a factor of 3, which means 0, 0 doesn't change because 0 times 3 is the same thing, but this one becomes pi over 4 comma 3. This becomes negative pi over 4 comma -3, right? So that's 3 tan x. Now we're going to replace the x with 2x. That means horizontal compression by a factor of 1/2. Because what happens, instead of going from negative pi over 2 to pi over 2, it goes to half of that. So it goes from negative pi over 4 to pi over 4. It has an effect along the x-axis. So t is pi over 2, which means we're going to go from negative pi over 4 to pi over 4 for a complete cycle. So this pi over 4 cut it in half becomes pi over 8, 3. And this negative pi over 4 cut it in half, negative pi over 8, -3. This vertical asymptote of x equals minus pi over 2 becomes x equals minus pi over 4. And this one, which is pi over 2, becomes x equals pi over 4. This is 3 tan 2x. And as you can see, the x-intercept, as I said, replace the pi with pi over 2. So 0, 0 doesn't change. But over here was pi 0. Now it's pi over 2, 0, so on and so forth. So the main thing to remember is the effect that it has on the period, and you can figure out what happens. y equals 3 tan x over 2. So it's similar to what we did, and eventually we deal with that. And it's important to understand t is pi, and now t is pi over omega. This means half of x, everybody. This means omega is 1/2. This means t is 2 pi. So just in case, so just to give you an idea, first let's just look at this function. So this is going from minus pi over 2 to pi over 2. Now it's going to go from x equals negative pi to x equals pi. One complete cycle. That's what happens as a result of this. This is what I want you to see. Now, as far as this one is concerned, the V8, replace the pi with 2 pi. 2 pi divided by 2 becomes pi, and that's why we get 2n plus 1 pi. Replace the pi with 2, this becomes a 2n pi 0. So in short, this becomes the graph. And of course, you multiply by 3, so it stretches by a factor of 3. Okay, just to give you an idea. And so let me erase this. So multiply by 3, vertical stretch by a factor of 3. That means just as the previous page, this becomes 3 and this becomes minus 3, right? Now we're going to replace the x by half of x, or x over 2, and that's the horizontal stretch by a factor of 2. So again, from negative pi over 2 to pi over 2, we are looking at a complete cycle. It's going to go from negative pi to pi as a result of that. Notice x equals minus pi, x equals pi. This is the effect of x over 2. And so here's the graph of y equals 3 tan x over 2. And as I've mentioned, the vertical asymptotes, 2n plus 1 times pi. And again, going back to the x-intercepts, 2n pi 0, notice, besides 0, 0 is 2 pi 0. Okay, and then the next one would be 4 pi 0, and so forth. Let's look at cotangent, y equals cotangent x, and we are going to do the same thing. We're going to just pick pairs as follows. Starting with pi over 6, we know the answer is square root of 3, pi over 4 is 1, pi over 3 is square root of 3 over 2, pi over 2 is 0. 2 pi over 3 is the same as pi over 3, but in the second quadrant is negative, so negative square root of 3 over 3. 3 pi over 4, negative 1, because pi over 4 gives you 1. And 5 pi over 6 is the same as pi over 6, but it's negative because it's in the second quadrant, so minus square root of 3. Okay, so we have, I'm assuming we know the value for common trigonometric functions, arcs, you name it, angles. And so if you graph one complete cycle, okay, what happens at 0 class, remember cotangent is cosine over sine. Cotangent is cosine over sine. So wherever sine is 0, you get what? Vertical asymptotes. In fact, just go back, I want to show. It looks almost like y equals minus x cubed, but remember minus x cubed goes through 0, 0. So to just sort of remember the shape, think about y equals minus x cubed. And again, this is cosine over sine. So wherever sine is 0 class, which is n pi, that would be the vertical asymptote, continues indefinitely on both sides. Cotangent is cosine over sine. Domain is all real numbers except when sine is 0. which means x can't be n pi. Range is just like tangent or real numbers, it's an odd function. And vertical asymptote, as I mentioned, sine x is 0 or x equals n pi. X-intercept happened at where the numerator is 0. Cosine is 0 at odd multiples of power 2, 2n plus 1 times power 2. Okay, pretty straightforward. Y equals cosecant x. So for that, we know cosecant is 1 over sine. So we graph y equals sine x, and then we flip it over. So it goes like that, like that. And the black one is sine, the blue one is cosecant x. So what are important facts about them? Since it's 1 over sine x, sine x can't be 0, so the domain is everything except what makes sine 0, which means n pi. Range is all real numbers except between -1 and 1. It's an odd function, just like sine. T is 2 pi. Vertical asymptote where the denominator is 0, x equals n pi, and doesn't have any x-intercept. So when we have cosecant x, 1 over sine x, domain, whatever makes the denominator 0 is excluded. I want you to look at the domain versus VA. VA, whatever makes the denominator 0, domain, what makes it not 0. Range, anywhere between -1 and 1, we have the sign. So beyond that, so negative infinity to -1, union 1 to infinity, it's an odd function, t is 2 pi, and VA is n. And it never crosses the x-axis, the basic cosecant function. When we look at secant function, we know it's 1 over cosine. So we graph y equals cosine, which looks like this, and we flip it over, and we get the secant functions. So secant is 1 over cosine, which means, of course, has the same period t equals 2 pi, which means it's even just like cosine. Now, as far as the vertical asymptotes and the domain, cosine x, for the domain, cosine x can't be 0. Cosine x is 0 at odd multiples of power 2. So x can't be 2n plus 1 times power 2. VA, vertical asymptotes, would be those, 2n plus 1 times power 2. And there is no x-intercept, the same range as cosecant x. So I hope you see that what helps understanding and remembering this, knowing that secant is 1 over cosine, and you can easily come up with all of those. Okay, very straightforward, everybody. Okay, let's look at an example. Y equals 2 cosecant x minus 1. And we write the basic one, y equals cosecant x or 1 over sine x. Domain x can't be n pi. Ranges from -infinity to -1 union 1 to infinity. It's an odd function. T is 2 pi, VA x equals n pi, and there's no x. So T is 2 pi. Domain is the same thing, and VA is the same thing because we are dealing with cosecant x. So period is 2 pi. Domain x can't be n pi, VA x equals n pi. So we want to graph cosecant x. We start with sine x. Then we flip it over and it becomes cosecant x. We are going to use the 2, so we are going to multiply this by 2. That means stretch it by a factor of 2 in a vertical direction. So if I want to stretch it in a vertical direction, what happens is that the x doesn't change, but the y, 1 becomes 2, negative 1 becomes negative 2, this negative 1 becomes negative 2, and so we end up with the following. Same vertical asymptotes, but this point now has been stretched as follows. We are going to subtract 1, so we graph 2 sine x, okay? The second method is to graph 2 sine x and then flip it over, okay? 2 sine x would be like this. Just to give you an idea, 2 sine x. Okay, y equals to, you could do that. Okay, now subtract 1, that means shift it down by 1 unit. So if I want to shift it down, that means now power 2 comma 1, negative power 2 comma negative 3, 3 pi over 2 comma negative 3. I am subtracting 1 from the y coordinates. So that's the graph of y equals 2 cosecant x minus 1. So transformation has not had any effect on the domain or the vertical asymptotes, but it has changed the range. Notice it can't cover from negative 3 to 1. So the range becomes minus infinity to negative 3 union 1 to infinity. So it has affected the range, okay? For example, the range for this one would have been minus infinity to minus 2 union 2 to infinity for this one, okay? Example 5, 2 hallways of 3 feet and 4 feet. This is 3 feet, this is 4 feet wide. Meet at a right angle. This is what they mean. Show the length of ladder L. This one is 3 secant theta plus 4 cosecant theta. All right, so we want to look at the length of this piece. To look at the length of this piece, notice this is because this is theta. Okay, these two lines are paired. This is theta. This is theta. So let's call this distance x, this distance x, and let's call this distance y. So L is x plus y. So this is, we know this is 3 feet, this is 4 feet. And so we want to find L, which is the sum of x. Again, this is x, this is y, x plus y. All we have to do, figure out what's x and what's y. So we are going to look at this triangle. And in that case, this is theta, this is 3, this is x. Cosine theta is the adjacent 3 over x. And therefore, x is 3 over cosine theta. In the case of this triangle, we have 4. This length is 4. This we called it y. This angle is theta. So in this case, sine theta is the opposite 4 over the hypotenuse y, which means y is 4 over sine theta. And so we are going to replace the x with 3 over cosine theta and y with 4 over sine theta. As you know, 1 over cosine is secant, so this is 3 secant theta. 1 over sine is cosecant, so 4 cosecant theta. And believe it or not, that's the proof. We proved that would be the case. Let's look at this example, an interesting way to look at this. First, I want to remind you when we are dealing with secant, it means 1 over cosine. Domain, anything that makes the denominator 0 is excluded. That's why 2n plus 1 times power 2. VA, the same thing, just make it equal. Here's the range, so forth, so on and so forth. So we should know that. And so to figure this out, first we start with the fact that y is secant x, 1 over cosine x, and we want to graph this. So we start with this fact. And so we're going to graph cosine x and take it from there. But first, what is it? T, 2 pi over pi over 2. So we are going to go with the cosine and then secant class. So graph of y equals minus 3 cosine of pi over 2x will result in the graph of y equals negative 3 secant pi over 2x. So we are interested in this, and then we'll flip it over. So the period is 2 pi over 2, which makes it 4. So a sine function that instead of 0 to 2 pi goes from 0 to 4. Notice this is 0, this is 4. Class, let's just look at one complete cycle is instead of 2 pi, okay? So this is cosine of pi over 2x. We are going to look at cosine of 3 times cosine of pi over 2x. Which means we are going to stretch this by a factor of 3. This 1 goes to 3. So this is 3. Then we go to negative 3 cosine of pi over 2 over x. That means if I'm going to negate this, I'm going to flip this over. Flip this over. So this is cosine. To get to secant, that would be the function. Y equals negative 3 secant pi over 2x. So from cosine, we go to secant by drawing those graphs, which is at top of those. Remember, this is a cosine. This is negative 3 cosine pi over 2x. All right. So the period is 4. And if you want to discuss this topic, see how easy you can do that. Remember, t must be 2 pi normally. But if t is changed to 4, change the 2 pi to 4. Meaning, if I want the domain, everybody, 2n plus 1, instead of pi is half of 2 pi. Put half of 4. So put half of 4 here. Put 2 here. And the same thing here. Put 2 here. I hope you understand how the transition works. T is 2 pi. Over here, you have half of t. So over here, you put half of t, which is 2. When you do that, 2n plus 1 times pi over 2 becomes 2 over 2 or 2n plus 1, which is the same for VA. This is the domain. This is the VA. And then clearly the range from -3 to 3 is excluded. That means from -infinity to -3 union 3 to infinity is the range of this function. Okay. -3 to 3 is excluded. Whatever the range of the cosine is, take it out. From negative to positive infinity, take it out from negative to positive infinity, and it becomes the range of secant. Now, what I want to quickly show you a second method on that maybe you find that easier. Okay. So graphing y equals -3 secant pi over 2x, we start with cosine and secant. So you graph the cosine and secant, just flip it over like that. Okay. So this is basic cosine. The red one is basic cosine. The blue one is the basic secant. So we multiplied by 3. So if you go back to this basic cosine to make it 3 times cosine x, the y-intercept of 0, 1 goes to 0 to 3. 0, 3. So this stretches, the red one stretches by a factor of 3. Now flip that over 4. So the red one is 3 cosine x, and the blue one is 3 secant x. So far, so good. Now let's go with the negative number. So basically, to go to -3 cosine x, flip this one over with respect to the x-axis, and then this goes up, this goes down. So -3 cosine x and -3 secant x. So to get this one, since we have a 3 cosine x, again, this one, flip it over. Look at the red one. Red one is flipped over with respect to the x-axis. And so those 3 go down, those 2 go up. So from here to here, I hope you see the transition. The period is 2 pi, but for this one is 2 pi divided by pi over 2. To get this, we have to write the new t, which is 2 pi over 2, which is 4. So what happens is that over here goes from 0 to 2 pi, or over here goes from 0 to 2 pi. Over here, if you see this number, okay, this is 6 something. Remember, 2 pi is 2 point times 3.14, roughly 6.28. So this is about 6.28. So one complete cycle. Just take a look at one complete cycle here. Of cosine in both cases. In all 3 cases, even when it flips over, it's from 0 to 2 pi. Now the 2 pi changes to 4. It's going to go from 0 to 4 because the period of 2 pi has changed to 4. Take a look. If you look at this one is almost 6.28. Okay. But if you look at this one, look at this one. What is this number? This number is 4. That's all you have to do. And this actually shows the numbers. For example, here -2, 3, okay, because of that number 3 that had an effect, it stretched it by a factor of 3. So this is -2, 3, this is 2, 3, and so on. Now, as I mentioned, we can calculate t equals 2 pi over power 2, 4, replace the pi with half of t, which is 2, and you get these values as the previous page. So I showed you all those steps, and you can figure out which one is the faster and easiest for you to do.